And I'm going to leave the Zoom. Peace.
And we are live. Straight from sunny Amsterdam to your home offices around the world, everywhere, or the garden, as well, the park, actually, as Tom is spending his time.
Hey.
Welcome to the community office hours. Today we're doing a Microsoft Ignite deep dive, where we're going to be looking at Azure AKS with Terraform and Consul. Maybe if we have some time, we'll also look at the HashiCorp Consul service, managed service for Consul that gets you up and running in way less time than it takes to normally deploy a Consul cluster. So lots of things to do here. Before we kick off, a quick note. We have some community guidelines. I know y'all are always super nice, but just to be sure, make sure whenever you respond in chat to be welcoming, inclusive, and friendly. Be considerate and respectful. As my mom would put it, just be a nice person. We've got the full code of conduct on our site. So if you want to head over to hashicorp.com/community guidelines, you can do that too. And we can go from there. My name is Kerim Satirli. I'm a senior developer advocate at HashiCorp, where I focus on my favorite tools, Terraform and Packer and others. And with me is the engineering lead for the Azure provider, Tom Harvey.
Hey, yeah, I'm the engineering lead for the Azure provider.
Nice of you to join us from beautiful Berlin. I love that background. That should be the new the standard background that we have whenever we have one of these sessions.
I mean, I can recommend it.
Yeah, it's definitely better than just hanging out in an office. I mean, I too have some green behind me, as you can see on my blurry background, but it's definitely a different world. Hey, so Tom, first of all, what do you do at HashiCorp as the engineering lead?
Yeah, so my job is primarily working on the Azure provider. So that's everything from building new resources for new things in Azure, adding feature requests, helping the community grow, that type of thing. So basically anything to do with making Terraform and Azure work well together. And we've got a team of 5 of us now, which is great.
And so when you build new resources for the provider, how often do they get released?
Yeah, so we throw one out every week. So we do releases on Thursdays, same as most of the other providers. And people seem to really like that, which is kind of nice. But there's always quite a selection in there.
I mean, there's definitely a lot of good stuff coming. We've got some code for today's deep dive that I want to actually walk you and the audience through. So why don't we jump right in? And I'll start by sharing my screen.
Let's do it.
Which has a 1 in 2 chance of working out. So if everything worked out, you are seeing my editor.
Works for me.
Awesome. And we'll start right. As you can see, I've been deploying some stuff prior to this session, just to make sure. If you're following along at home, we'll get a link for the repository up in the chat. And if you have questions, you can also drop them in chat. We've got our moderator, Katie, who will drop the questions in a way that we can see them and respond to them. So if you have questions about the Azure provider or what we're doing here today, just let us know and we'll try to get to them. So if you're doing a deep dive, chances are you're fairly familiar with how Terraform works. And just to set the ground rules, we're starting out with the Azure provider 249, released last Thursday. We've got the Consul provider in here, and that's pretty much it for our base repository. Then to make our life simple, we're going to be deploying an application on Kubernetes today, and we're going to be using AKS. And so one of the coolest things about Terraform is that you can abstract building blocks into modules. So what you see here is that we're actually using an upstream maintain module for AKS, the Azure Kubernetes service. We're version pinning this to 4.8.0, just to make sure that whatever works today will also continue working in the future. If you've worked in engineering long enough, then you know that version pinning is a good feature and something that you want to use pretty much all the time, because things do get freaky when you don't. And we'll build from there. So first thing we run into is that we need a resource group. Easy enough, we've got a Terraform resource for that. So we'll dynamically reference that. And then comes the next part. We want to define an agent count. And that's something we'd like to dynamically modify. Normally, as with, for example, disk size, you could just hard code those values. For our agent count, we're actually trying something a little bit different. And you can already see from the comments that we left in the code for you that we're actually doing this by pulling data from Consul. And let me just move my mouse away. And while I open this in the background, which of course is in a different window than I'm sharing, let me quickly reshare the right window for this.
All good. Cue some hold music.
Yeah, if you want to sing something right now, that'd be probably a good moment. There we go. So you should be able to see a locally running Consul service. I'm using Shipyard for this. And if you join us for one of our upcoming HashiCorp Live editions, I think next Friday maybe, we'll be talking more about Shipyard, which is an easy or easier way of getting a couple of services spun up locally and reliably. So to start out, we've got an agent count set to 3. Nothing super special. We're trying to keep it approachable here, but we could make this much more complex. So let's switch back to our code base to see what we're actually doing with this. So we know we're looking up a Consul key. So let's start here. First of all, we need a Consul server that we can connect to. The easy part here is because we're running it locally, we've set this up to be available via Shipyard, so we can just retrieve our information that way. As we're pulling Consul through Terraform, we've got a data source for Consul keys, which allows us to retrieve the keys, either singular or plural, that we need. So for us, we're starting out with a cluster configuration and specifically an agent count. And in the absence of that value being correctly defined, we'll default to 1, just to be on the safe side, because our cluster should have at least 1 agent. But if there's any other number, that should override what's in there. And let's go back to our code base. So for our Kubernetes cluster, the goal is to deploy an application. And we know we want to have HTTP access. So we're enabling a couple of different flags here, setting a couple of versions, and essentially just making sure everything is nice and tight. And while we run this, I believe I actually deployed this one already to shave down some deployment time. But we've done these demos live, and generally AKS takes an amazing 4 to 6 minutes, which when you think about it, they must be available in hot standby. Curious, Tom, do you have any insights into why Azure is so fast with deploying AKS?
I'm assuming it's similar to what they're doing with other VM scale sets, where they basically spin up twice as many and then take the first. So if you press 3, they'll spin up 6 and then take the first 3 that come up, which is, yeah, an interesting way of doing it.
Seems wasteful, but hey, as long as it gets me my stuff quicker, I'm all for that.
Yeah, I mean, there's trade-offs to it. It's interesting because you get VMs go through different processes on different hosts. So it's kind of an interesting trade-off, but it seems to work. So, you know.
It definitely does. I mean, having a live demo where you can actually spin up a full cluster from 0 to working in less than 10 minutes is amazing, especially if you're not doing it locally. So let's have a look at what we're doing here. We've defined our agent count, and we've got our Kubernetes cluster running, but we've also got a depends on. And as with all problems, we're dependent on the network. So what are we doing here? Let's quickly open networking TF, and we'll get to the question on how to learn and understand Consul in a second. When you want to build Terraform resources, the best way to approach it is to think of your whole infrastructure, or the best way I like to think about it is as a Lego set. You've got lots and lots of small pieces that make it up, but you've got a lot of parts that look the same. And those parts you can modularize, as with, for example, the networking module. So what we've done here is we've got an upstream maintained module, actually maintained by the Azure team, that allows us to set up a network, including an address space that we need, any subnets, the naming, and everything else that goes with it. Very straightforward, and it's a solved problem. When you're building infrastructure, having to reinvent the wheel all the time is boring and error-prone. So whenever you can depend on code that's maintained and maintained well, I would absolutely recommend doing it. So we've got our network module here. And just to show you that this actually did get deployed, let me grab our network settings from the Azure interface, which is always a little bit trickier. There we go. So if you remember from the beginning, we had a resource group called Platform. And the zoom in is actually making it a little bit harder for me to click on there. I apologize for the technical troubles there. There we go. And we've got a couple of things deployed here. You'll notice our Kubernetes service, our virtual network, and hopefully, if we get to it, our primary Consul cluster. And switching back to our code real quick, we've got a working network. So far, we're 16 minutes into this. We are at twice that many lines, about 40 lines of code. We've got a working Kubernetes cluster. We've got a network. This is going well. So now you might wonder, hey, they're pulling data from Consul. What's a good place to learn from, to learn how Consul works? And a good way to understand it. So my first recommendation is check out our Learn site. And we'll get a link for that up in the chat. It's learn.hashicorp.com/Consul, where we have a good selection of tutorials on the various parts of Consul. Consul as a product has a couple of different sites that you can be interacting with. Today, we're going to be looking at specifically the key values, but you could work with intentions, the whole service mesh interface. There's way more than fits in a single hour demo, unless we make the demo all about Consul. So I would recommend go there, start there, and the tool is free. So as with all our tools, download the binary and start experimenting with it. If you are able to write Terraform code, then you're already familiar with HCL, the same underlying language that we use for Consul configuration. And it's fairly easy to go from there. So if we go quickly into our Consul service, just to show you, same language, again, HCL. We're starting up. And if you're checking out this repository at home, also a great way to get started. We've got some code in there to get you a local Consul server, including data hydration, which means data insertion, where we're making sure you have the right values in your Consul KV store that the Terraform code depends on. So you might wonder why, if there's variables in Terraform, are we pulling data from Consul? And that's a really good question, because doesn't that make it more difficult? And the answer to that is, as with most technical things, it depends. In today's scenario, what we're trying to do is we've got 4 separate code bases, which you'll see. I don't know if my sidebar is clear enough in terms of visibility, but we've essentially got a Kubernetes code base, an Azure code base, a Consul code base, and a Datadog code base. And all of these interact with a similar type of resource, but they're loosely coupled through Consul as one of the moving parts, and on the other side with resource groups. And so that might sound a little bit confusing. I give you that. We're going at a high speed here. It's a deep dive. We're trying to get down to the bottom quickly. So if this is hard to follow along, just drop us a note in chat and we'll slow down.
Is it
So
also worth mentioning that those are split apart? Like, they don't have to be split apart. This is just split apart for the purposes of like simplicity, essentially. But you can absolutely merge them together and have, you know, console referencing Azure in the same module if you need to, or any combination of anything.
Absolutely. It's, as with most technical decisions, it depends on the architectural style you need. We're going for a loosely coupled approach here, but you could have your Consul cluster and your Azure resources and everything else defined in a single repository, or even in a single code base. We're splitting the code bases by having 4 different subdirectories, while they're still in a single repository, mostly for ease of use of our end user, you, but you could definitely merge them. So if we go back to our AKS cluster, we've defined everything here, and when we run our apply, nothing should come back because everything has already been applied. But it's always good to just make sure we didn't make any changes that would require reprovisioning, destruction, or initial provisioning. And I just realized I'm actually in the wrong subdirectory. So let's try this again in the Azure one. Of course, there would always be a bug somewhere. Give me a sec while we fix that. I think may have chucked away. Yeah, there we go. The beauty of live demos is always making changes last minute, realizing, hey, you know what, this would be much cooler to show, and then doing things like throwing away your variables file, which of course Terraform depends on, and would then be unable to find. And with a variables file restored, we're good to go. So what you're seeing here right now, Terraform is going through all the resources we provisioned and making sure all the changes are correct. And we can see these long URLs that we can't even get on the screen fully are some of the outputs we defined just to make it easier. So if you're following along at home, you'll be able to run your Terraform apply, and at the end, when everything is done, you'll have ready-made URLs to click and go into your managed cluster, into your resource groups, and just inspect everything in the console or in the portal. And so to show you that this is not just smoke and mirrors, let me open up our cluster here. We've got a node pool. We've got a node count of 3 with a node size of DS2, D2S, V3, all as we defined in our Terraform. I'm pretty happy with that so far. Now, of course, the next question is, what are we going to do with our cluster? And for that, let me switch to the Kubernetes directory. Zoom interface not allowing me to click on that is a little bit frustrating, but we'll preempt that by essentially just pre-opening everything. So again, we start out with our Terraform definition file. We've got the Azure provider, Kubernetes provider, and if you're following along and using Terraform Cloud, we've got that set up at the bottom for you as well. So in the previous repository, we set up an AKS cluster. And for that to work, we now want to deploy something on it, because what good is a cluster that doesn't run any workloads? I mean, you got to run Minecraft somewhere. So to deploy a service, we've got Terraform Kubernetes provider and other options. We could use a Helm provider if we have Helm charts. But the question is, of course, how do we connect to the provider? So if we grab our provider documentation, we can see from the start that we need a host, client certificate, key, and a cluster certificate. All of those we have available already. We just need to know where we can find them. And so the way we loosely couple this is we use data sources. And in this case, specifically the data source for the Azure Kubernetes cluster. Tom, can you help me explain what the difference between a resource and a data source is?
Sure. Yeah, so a resource will let you create a new thing. So in this case, we've used one previously to create a Kubernetes cluster or an AKS cluster. In this case, we're using a data source, which allows you to get information about an existing thing. So in our case, to look up the Kubernetes cluster that's made in the other module, and then retrieve a bunch of things. So you can obviously see we're specifying the name and the resource group, but that also gives us a bunch of other information. So the DNS name, the Kubernetes config as we're using on line 22 below, also the tags and that type of thing. So basically gives us a bunch of information about an existing resource, and these exist for all kinds of resources as well.
So essentially, if you're talking about it in a REST API format, this would be clearly a read resource.
For sure. But what's interesting is you can use these to break your configurations apart as well. So similar to what you're doing, where you can have one module that just reads information from another thing. So you might have like a networking team define that centrally, and then have service teams individually all define their own modules that look up existing information. So be that a subnet or an AKS cluster or whatever else.
And you made a good call out here that we're actually using data from this resource already. So let's quickly hop into Terraform console and have a look at what is in the data source for the Kubernetes cluster. So Terraform console, if you haven't used it, is, for me, definitely the best way to explore all the data that data sources have, but also that resources have. So we'll start out by typing the same shorthand that you use normally in Terraform. In our case, that's data.azure-rm Kubernetes cluster with the resource identifier current, and that's already it. So unless you have a high-speed photographic memory, you just saw roughly 720 lines flash by, which is our full definition of our cluster. And this tiny resource, all we're talking about here is 4 lines of code, allows us to get everything from our cluster that we need. And that's honestly quite powerful. We've got our identities and everything else. And so if we take this as an example, give me a sec. Our actual kube config.
Yeah.
There we go. Don't need to clear in this one. There we go. You'll also see part of our CA certificate and everything else. And passwords. Don't worry about breaking into these. We're going to unprovision them at the end of this show. But if you get in there, our Minecraft image needs an update. So if you can get to that, that would be highly appreciated. So as you're looking at the code base, you'll notice that in order to get this running, and let me just go ahead and open the right files here again, we actually didn't need to provision any new Azure resources. We got what we needed from read-only resources, and the two were very loosely coupled. Our only search key that we needed was the AKS name and the AKS resource group, which we stored in Consul in the previous repository. So now, of course, the next question is, what are we going to do with all of that? And the answer to that, we're going to deploy a very simple Nginx container that my friend Taylor works on. It's called Beacon. And we're going to just do that live.
Exciting.
Well, hopefully. Otherwise, we'll have to come up with some good fill material. So as this is running, in the meantime, Terraform, since I've run this a couple of times already, I like making sure my demo code works. Terraform is actually checking if any of my resources have changed in the meantime. And we'll make sure that those changes match, get undone if they don't match what I've defined in my code base. And so I'm curious, Tom, how does Terraform do that? Is there a simple way of explaining how that works?
Yeah, so when you run Terraform apply, Terraform plan, or Terraform refresh, what we'll do is the same thing. So we look at every resource that's tracked in a state file. So it's everything we've created or everything you've imported. And then we'll go through and, as it's saying here, refreshing the state. And so what that actually means is looking up to see if it still exists. And if it doesn't, then we'll remove it and say that it needs to be recreated or whatever. And then we check the properties for that as well. So in this case, we're pulling the Kubernetes namespace, we're seeing it exists, that's great. And so we know everything within that. So the deployment and everything else still exists. And then, then there's other items under that. So we can see like the number of nodes in the AKS node pool, that still exists. And there are 3 of them. Somebody's not played with it manually and scaled or either way. Yeah.
So essentially, this sounds like if I have somebody who goes into the portal and makes changes there, those changes wouldn't stick if I run Terraform again.
Exactly. As long as you've defined it, as long as you've created the resource with Terraform, we should be able to track the state in it. And so, if someone makes manual changes, like of any sort, to adding a tag or changing the cluster from Linux to Windows or whatever they're doing, like bigger scale changes, we can track it that way. So
the simple
cool.
ones, right? Essentially, completely changing the underlying OS and everything.
I mean, you might wake up in the morning and just decide you need to change things. Yeah.
That is definitely a possibility. So in our case, we've defined a Kubernetes deployment, namespace, and what else did we define? Oh yeah, service, of course. And if you're going through the code at home or wherever you are right now, hopefully in a park like Tom, you'll notice that we're making a lot of references. We're trying to hard code as little as possible because that means we have to change as little as possible. So for example, in the Kubernetes service, we're making a reference to the name of the deployment because we want those to be the same. Your organizational architecture, infrastructure architecture might be different. For us, this works because it removes the overhead. We've got a namespace that's called Beacon. We've got a deployment called Beacon, and we've got a service called Beacon. Keeps it simple. We also do the same for the tags and selectors. And I think the only thing that we've hard-coded is the port here, and I think I'll get that out at one point, but that's not for today's session.
It's probably also worth pointing out that it infers the dependencies for us, right? So we know that to create the namespace before deployment, before anything else. So it's pretty handy to have them referenced, both in terms of less code to write, less places to change things, but also just in terms of, yeah, it's handy from that perspective to make sure things get created in the right order.
I think handy doesn't even cover it. It's definitely handy, but it's also, it just removes so much mental overhead of having to remember, okay, wait, so I want to call this Beacon and I need to change it now in 1, 2, 3, probably 5, actually more places. And that's just for a single service. Anything that's hard-coded will eventually get stale. So the few places you have where you hard-code data or strings or configuration, the better. And whenever you can use references, definitely do. And this is pretty much also the underlying story of the loose coupling that we have here. We're trying to make sure that you can have a repository that deploys your AKS cluster. And today we're talking AKS, but you might have to run this on premise. If that's the case, I'm sorry for you, but there's ways around that. But in any case, you don't want to be tied to having to remember that you need to update your Azure code base for Terraform, your local code base. Maybe you have multiple clusters in various regions around the world in Azure. The more you have hard-coded, the more likely you are to have a misconfiguration that will eventually bite you. And of course, you could do things like policy enforcement, but even that will only ensure that you're deploying the right stuff and not necessarily catch anything that's hard-coded. So when you're thinking about making your code more reliable, which is what we're trying to do here by removing tight coupling, make sure you think of it in layers and improve various parts as much as possible without over-engineering it. In the meantime, I saw a a question on Consul service. I think my colleague Rosemary is going to be answering that in the chat if she hasn't already. So that's great. And in the meantime, let me pull up my local Consul cluster. There we go. And
It's worth saying it's really easy to get Consul set up locally as well. It's a one-liner, so
it's beautiful how simple all of this is. And so if you notice, we've got our cluster name in here. And this was actually written by our Azure code base that we looked at probably 15 minutes ago. So quick reminder, we'll go in here. In Consul keys, we are writing the the AKS cluster name to the path cluster-data /AKS name. And what we're doing for that is we're actually grabbing the module outputs. So again, we're not using hard-coded strings, we're using dynamic references. Life gets so much easier when you don't have to think what you need to change here. And that ends up being this beautiful string. And so, Tom, I had an interesting question that a friend of mine brought up. he was deploying an AKS cluster last week and was like, hey, so I'm using Terraform, but my instance resource comes out as whatever name I give -AKS. Why is that? I figured, you know what? I'll ask Tom. Maybe he knows.
So it depends. AKS behind the scenes deploys a bunch of things for you. So a Kubernetes cluster is obviously not just one thing, it's a whole bunch of things. So you give it a subnet and a list of machine sizes to deploy for the agents, and it goes and runs some things behind the scenes. So AKS itself spins up the control plane and then multiple agent pools, and each of those has to have a unique name. So in this case, it's suffixing AKS on the end of it, just because that's a unique name for it. And then the node pools are the same. I believe it starts out with default is the name of the default node pool, but I might be wrong. But you can name them whatever you want as well, which is really handy if you want to call some like GPU or some Windows or Linux or whatever you need to call them.
Depending on the type of underlying architecture or service architecture, it's generally nice to be able to give your instances and services the right name. Thank you. So I'm really hoping that Igor had a chance to hear that answer. If not, I'll make sure to send him the link. Because I was also like, yeah, that's an interesting one. Because as you can see here, I am actually defining it just as dynamic-infrastructure. But for the reasons Tom explained, it ends up being dynamic-infrastructure -AKS. So as we're waiting for this, as we're talking about this, our Terraform Kubernetes deployment actually finished, which is nice. And for you to follow along at home, we've added a couple of outputs to your various resources inside AKS. And these are dynamically generated. I can actually show that by going there. Based on the inputs and outputs that we get from our various modules, data sources, and everything else. And what this does is it gives you an easy way to just click on, end up in a portal. So if you are new to Terraform, if you're learning how a provider works, it's one of the nicest things is to deploy something with Terraform, make a change to your infrastructure, and then go into the portal of your cloud provider and have a look at, hey, what did I actually do? And let me tell you, that first moment when you deploy a network or a storage bucket or what have you, and it shows up in the portal, it's quite magical. It's that little success moment that, brightens up your day. And that means that, hey, you just earned that flat white. So in the meantime, for us, this all worked out. I know we have an application running now. And let me just pull that up in my browser. And here we go. You can see we're on 20.71.74.134. So if you're following this at home, feel free to visit the page and enjoy it as much as possible. It should take about 2 seconds, given the amount of information there. And we'll continue in the meantime. So got about 16-ish minutes left. Let's see, shall we try to deploy an HCS cluster? Because honestly, it's nice to be able to run Consul locally, but all of us are working at home. And I personally don't want to open up my internet for Tom to be able to connect directly to my machine. So it might be easier to just have HCS running remotely. And so I've got some code prepped for this. And so HCS is the HashiCorp Consul service on Azure. It's a managed service, which means we will run Consul for you. And the cool thing about that is that you essentially, all you need to do is tell us you want it, and we'll set it up for you. Now, of course, that Consul service is not limited to just key values. So it's a fully working Consul service. You can do federation between clusters. You can do everything you want to do. pretty much, what it says on the packaging is what you get. So first thing we'll need, as before, Azure provider. And because we like codification, we're not going to be doing this in the cloud by clicking. Actually, let me see if I can show you how this would look like. We're not going to be doing this in the Azure portal, which would be the wrong approach. Or not necessarily the wrong approach, but it wouldn't be the best approach. We're going to be doing this through code. And for that, we're going to be using the HCS service. And there we go. Got my So I've got a running service here, but sometimes finding the right window to click when you're deploying things through Consul can be hard. So first thing you might notice is, okay, how do I even get started with HCS? And that's a super good question. We've got a beautiful tutorial on our Learn side, and we'll get a link for that up in the chat. And just to quickly show you, everything you need is there. How do you connect things? How do you deploy the service initially? I believe the connecting your own VMs question is also handled there. And
also worth adding in the sidebar, you've got one for AKS as well, right? So you can add a console container and register things through AKS directly.
It's beautiful how it all works together. So
that's pretty cool.
I personally am not a big portal fan. I love Portal the game. I just don't like any cloud portals because they make you click things and not remember that you clicked things. And that usually ends up being a problem at 3 a.m. when your pager goes off. So rather than click on this beautiful create button here, which would take us through the whole process, we're just gonna slide this window to the side and go back to our code. So we've got the HCS provider here, which is the HashiCorp Consul service. And let's just use that. So we'll start by defining a market or agreeing to a marketplace agreement, which sounds confusing, but because it's a managed service, we're gonna need to do that. And as Tom and I were prepping for this session, we'd already done this. So I don't need to do it again. Also, we have a shared account, so somebody else has agreed to it in our shared account. So hence, for us, this resource is normally commented out. But you notice I'm making a new Terraform resource here using the Azure provider to agree to a marketplace agreement. And normally this would involve going into your browser, clicking something. And if you work with any of the teams I work with, usually that's one of the acceptance, or sorry, not the acceptance criteria, the definition of ready items in your ticket. So Scrum Master would try to unblock you. They'd go into the marketplace, click OK, and it would be good. And you could just start working on this. Now, our problem is, if that happens, you have no knowledge that this was agreed to. You don't know the next time you deploy this to a new account that that's what's actually needed for you to be able to do this. So by having this codified, much nicer. So we've got our marketplace agreement, and
so worth clarifying explicitly that a marketplace agreement is like the T&Cs for this product. So for HCS.
For HCS, exactly. Yeah. You're agreeing to a couple of other legal definitions. And I'm not a lawyer, so don't just randomly click OK. Make sure you understand the agreement. Make sure you know what you're agreeing to. I know enough to be able to do this. So let's have a look at what we're going to be doing. And so the first thing we want to do is understand which plans are available to us. And so we'll switch to this one here. And as you remember from before, data sources in Terraform console, super amazing, because you immediately can see all the data that's associated with the resource. And so as my console starts up, there we go. We'll just print out the right information that we have here. So what the offer name is, plan name, and pretty much everything that we might need downstream. And I'm also curious what our potential versions are. So let's have a look at that. So you'll notice available versions 1.80 to 1.93. And I'm mostly curious about what the currently recommended versions. And that's 1.93. Awesome. So this means if I use the string data.htl console version .default.recommended, I'm actually going to get the recommended version of console on HCS as a dynamic reference in a way that I can use it in my code. So let's go ahead and do that. I'm just going to quickly walk you through. We've got 10 minutes left. Quickly going to walk you through our HCS cluster setup. As with all Azure resources, you're first going to need to specify a resource group name. I'm curious, Tom, do you know why we need to specify that?
So everything in Azure lives inside of a resource group, or basically everything, which is everything. And because we're deploying this managed application, that lives inside of a resource group. So HCS and all of its components, similar to AKS, everything that it provisions for either AKS or HCS lives inside our resource group. What's really handy about that is it means that you can scope the permissions to that resource group or assign tags or whatever you need to. So resource groups are a really convenient way of grouping and delegating things together. You're muted, by the way.
Apologies. My Zoom was acting up a little bit. Hopefully we didn't lose too much, but so essentially we can think of resource groups as a folder if we're thinking file system and just putting things together.
Yeah, essentially.
Awesome. Easy enough. So we've defined our resource group. And as you notice, we're actually using a data source here. And the reason for that is that about 45 minutes ago, when we started out with our Azure code, we had already created a resource group in here. And I already know it's called platform. So rather than redefining everything here, I just use a data source because that will tell me which region I'm in and everything else. Makes my life easier and makes the code maintenance easier. And if you're following along with the code, no matter if it's now or later, we've made sure to include the registry URL with the documentation for every resource that we've used. So essentially in your editor, command click, control click, whatever works for your interface, and you'll see the information for that resource. So what else are we defining here? Managed application name. Again, just using a dynamic reference to our resource group name, which was platform. Could we have typed platform here like this? Of course. Would it be quicker? Yes. But what if things change? That's a question that you're going to be asking yourself at 3 a.m. when things go wrong. We're assigning an email here. I recommend you set this to yours and not to ours, but whatever works for you can work for us. We're choosing a production cluster mode, but I highly recommend checking out the documentation to make sure you understand all the values here. And we're setting up a VNet and a console data center. So altogether, 10 lines of code. And Tom, I think you said it takes about a minute to to deploy your local console. I'm 100%, I'm not able to beat that because we're deploying a fully managed console. But I'm pretty happy with how quickly this went, like prior to the demo. For some background for our audience, we had some fun just adding the HCS service in there. Last minute decision. Should we do this? Should we give people a chance to try that instead of having to run console locally? Let's do it. Wrote out the code, whole process start to finish, less than 10 minutes. And that, I mean, of course, includes reading through the documentation and waiting for the cluster to be provisioned, but it worked out. And that's 1 minute to start your own, 10 minutes to start something that's fully managed. Yeah, I'm a lazy person. I like fully managed.
Comes with backups and other things though, right? Like it says production there on line 6, but like that's actually production ready, which is super handy. So
yeah, I mean, pull requests accepted. If we can change this into production ready, that would be even easier. So as you can see, we've got a working console cluster as far as Terraform is concerned. Now, let me see if let's do a little bit of exploration here. I like putting things in outputs because that makes it easy for me to see what Terraform is doing. And it allows me to understand what data I have available. And so let's see if there's something that we can do in terms of getting a nice URL together. And I'm guessing the ID should work for this. And just copying that over to my browser. And then eventually, once we verified that that works, we'll change that and make it an actual output. So in the meantime, while that loads, ad blockers. There we go. And if you joined us 15, 20 minutes ago, you had already seen that we had this up, but you can see it here as well. Resource group platform as defined. West Europe, you might be wondering, but where did that come from? Because we never specified our region here. That's because we're using the resource group that we previously defined, and it's inferred. And so what data can we show here? Let's go with the console.
You've got console clusters down the left as well, right?
Yeah. So while this is loading, you'll notice that it took us almost no time to get this to work. Longest time is always waiting for my browser. And this is not a riff on the Azure portal. This is definitely a riff on my browser being very slow lately. So we've got our custom provider resource here, and we've got a couple of properties in here. And we can see the exact things that we specified. Platform, which is the resource group name, which we dynamically referenced. We called it the primary cluster because our goal is eventually to have a secondary one. We've defined data center 1. The current version is actually the version that's currently recommended, which we've defined through the .recommended version property. We've got snapshots. A good thing that you mentioned that. Very nice. So every day we're taking a snapshot. So if there's anything that doesn't work out, then we'll know that we have. I should have probably opened some things up And with 2 minutes to go, that might be a change that we're making in the code base. We'll get the link for that up in the show notes, sorry, in the description, as well as in the chat. So you too can play around with that. And so let's see if we can get the Consul UI to load, which would be the best part here. But I feel that that's going to be slightly dependent on ad blocking happening or not happening.
You should be able to right-click the URL bar, by the way, and disable the ad blocker.
The Zoom sharing window also makes this a little bit more difficult than it should be. But let's see.
If not, it's a definitely trust us, it works. It's deployed, it works. It's cool.
I mean, we can already verify that it works because it shows up in the portal. So there we go. I think with a few cookie settings a little bit more relaxed, that should be loading. And if not, then you'll just, like Tom said, have to believe us that it worked and that we were able to deploy it. So quick recap, if you joined us from the beginning, welcome, thank you for staying, and hopefully we'll see you back at one of our future streams. In today's deep dive, we deployed an AKS cluster using a couple of modules from the registry. In roughly 40 lines of code, we had our own Kubernetes service running, and then stored the name of that service inside Consul. And as part of the repository we're sharing with you, we've got a local Consul setup. But at the end, we also built a managed Consul setup, for which we were only unable to show you the UI of everything. In the meantime, on our Kube cluster, we deployed an application. We created a namespace, a service, and opened it up to the internet, and made sure that everything is loosely coupled. We're using Consul for the back and forth, and a couple of data sources. So essentially, read-only constructs in Terraform that allow you to retrieve information from your code, from your infrastructure. Then we deployed our application. We made sure we have a couple of useful outputs. And in the end, we spent the past 15 minutes deploying HCS, our managed Consul service. Pretty nice 1 hour. So if you joined us, thank you for the questions. If you have any more questions, drop them in the chat. Thank you, Tom, for joining us.
Thanks.
Any closing words?
Use HCS, it's great.
It's true. So with that, I hope you all have a great day, and we'll see you at the next stream.